Part 1. Boolean Algebra with Venn diagrams. Let's explore Boolean algebra with Venn diagrams. Circle A is blue. Circle B is red. Where they overlap becomes purple. A and B only the purple overlap is true. Both sets must contain the element A or B. Everything in blue, red, or purple is true. At least one set contains it. Not A. Everything outside the blue circle is true, including red only and the outside region. A and not B. Only the blue crescent, inside A, but outside B. A exclusive or B. The blue crescent and the red crescent, but not the purple overlap. Not of A and B. Everything except the purple overlap. This is De Morgan's first law. Not A, or not B. Same shading as before. De Morgan says these are equal. Not of A or B. Only the outside region, in neither A nor B. Not A, and not B. Same outside region. De Morgan's second law. Remember, the shaded region is where the Boolean expression is true. Part 2. Concrete sets, and Cartesian products. Now let's look at intersection with real set elements, not just shaded regions. Set A contains an orange pentagon, a blue diamond, a green square, and a yellow rectangle. Set B contains a red star, a green square, a green triangle, and an orange pentagon. The intersection of A and B is the elements they share, the orange pentagon and the green square. So A intersect B equals just those two shapes. Union is different. A union B keeps every element from either set, with no duplicates. We can also picture set operations with Cartesian products, rectangles on a grid. A times B intersect A times C equals A times the intersection of B and C. The yellow overlap shows that shared strip. For two products, A intersect B times C intersect D equals the intersection of the two rectangles. But watch out, A union B times C union D is bigger than the union of the two products. The purple corners are extra. Concrete elements, Venn shading, and coordinate rectangles are three views of the same Boolean ideas. Part 3. Categorical syllogisms. Categorical syllogisms are step-by-step arguments with two premises and a conclusion. We use S for the subject, P for the predicate, and M for the middle term that links them. In these diagrams, black shading means empty, nothing lives there. A red mark with an X means at least one thing exists there. Barbara. All men are mortal. All Greeks are men. Therefore, all Greeks are mortal. The Euler picture nests Greeks inside men, inside mortal. On the Venn diagram, we shade away Greeks outside men, and men outside mortal. What remains forces all Greeks into mortal. Celerant. No reptile has fur. All snakes are reptiles. Therefore, no snake has fur. Reptiles and fur are disjoint, and snakes sit inside reptiles. Dairy. All rabbits have fur. Some pets are rabbits. Therefore, some pets have fur. The X sits in pets and rabbits, which already lies inside fur. Ferio. No homework is fun. Some reading is homework. Therefore, some reading is not fun. The X is in reading and homework, outside fun. Barocco. All cats are mammals. Some pets are not mammals. Therefore, some pets are not cats. The X outside mammals cannot be a cat. Dirapti needs existential import. All squares are rectangles. All squares are rhombuses. And some squares exist. Therefore, some rhombuses are rectangles. Classically, there are 24 valid syllogisms across 4 figures. Names like Barbara and Ferio are old memory aids for the mood patterns. Same Boolean shading idea as before: empty regions, existing regions, and what must follow. Part 4: Higher order Venn diagrams, and information theory. Beyond 3 sets, Venn diagrams get fancy. John Venn looked for elegant shapes that still show every possible overlap. Four congruent ellipses, rotated around the center, make a symmetric 4-set diagram. Every combination of in and out appears as its own region. You can also use 4 ordinary circles in a 2x2 layout. It works, but it is less symmetric than the ellipse flower. Five ellipses, 60 degrees, wait, 72 degrees apart, make a star-shaped 5-set diagram. The very center is the intersection of all 5. Venn also gave a construction for any number of sets: keep the classic 3 circles, then weave a horseshoe curve through every region, then nest another horseshoe inside, and so on. Edwards' Venn diagrams come from slicing a sphere. 3 sets are like 3 hemispheres. The 4th follows a tennis ball seam. Higher sets become cogwheels with more teeth. Watch the build: 3 sets, then the green seam for 4, a 4-tooth cog for 5, and an 8-tooth cog for 6. The same overlap picture shows up in information theory. Circles are no longer plain sets, they are amounts of uncertainty, called entropy. For 2 variables, the left crescent is information only in X, the right crescent only in Y, and the purple overlap is mutual information. The whole union is joint entropy. With 3 variables, the outer petals are conditional entropies, the pairwise lenses are conditional mutual informations, and the gray center is interaction information, the only one that can be negative. So Boolean regions, syllogism shading, high-order Venns, and information diagrams are all cousins. Partition a space, then read what each piece means.